According to National Electrical Code, or NEC, Article 800.133, communication cables such as unshielded twisted pair, or UT, and coaxial cables from computers to outlets must be separated from power cables for computers by at least 2 feet. The NEC does not specify a maximum length for communication cables. According to NEC Article 770.93, in closets, communication cables such as UTP cables from switches must be separated from power cables and grounding wires by at least 2 inches. This separation can be achieved using spacers, barriers, or conduits. NEC Article 852 addresses several important concepts. Firstly, it discusses power-limited circuits in compliance with Article 725. These are circuits that carry low voltage, less than 120 volts, and current, less than 5 amps. They are not intended to power equipment, but may carry communication or control signals. Secondly, it references electric light, power, and Class 1 cables. These are cables that carry power or high voltage signals. Thirdly, it refers to exception No. 1. This exception allows communication cables to be run in the same conduit or cable tray as power cables if they are separated by a barrier. This barrier can be the primary or secondary coating of the power or communication cable. Fourthly, it refers to exception No. 2. This exception allows communication cables to be permanently separated from power cables by a non-conductor, such as porcelain tubes or flexible tubing. This non-conductor would be in addition to the insulation on the cables. The primary and secondary coating of power cables does not provide sufficient separation. A separate physical barrier, such as a spacer or conduit, is required to meet the NEC requirements. In summary, to comply with NEC standards, firstly, maintain a physical separation of at least 2 feet between communication cables from computers to outlets and power cables for computers. Secondly, in closets, ensure a separation of at least 2 inches between communication cables from switches and power cables, including grounding wires, using methods like spacers, barriers, or conduits. Thirdly, understand that power-limited circuits are low voltage, low current circuits used for communication or control signals, not for powering equipment. Fourthly, recognize that electric light, power, and Class 1 cables are used for carrying power or high voltage signals. Fifthly, utilize exception No. 1, which allows communication and power cables to share the same conduit if a barrier separates them. This barrier can be the cable's primary or secondary coating. Sixthly, apply exception No. 2, which permits permanent separation with a non-conductive material like porcelain tubes in addition to the cable's insulation. Seventhly, remember that the primary and secondary coating of power cables alone is not enough for sufficient separation. A separate physical barrier is necessary to meet NEC requirements. To elaborate further on the NEC guidelines, consider the specific requirements for different types of installations. Firstly, in residential settings, where computer and outlet cables are common, the 2-foot separation rule should be strictly followed to minimize interference and potential hazards. Secondly, in commercial buildings, especially in telecommunication closets and server rooms, the 2-inch separation is crucial for maintaining signal integrity and preventing electrical noise from affecting communication equipment. Thirdly, when dealing with power-limited circuits, it is essential to verify that the voltage and current levels remain within the specified limits of less than 120 volts and 5 amps respectively, to avoid overloading the circuits and causing damage to the equipment. Fourthly, for electric light and power cables, ensure that they are properly insulated and rated for the voltage and current they carry, and that they are installed according to the NEC guidelines to prevent electrical hazards. Fifthly, when using a barrier to separate communication and power cables as per exception No. 1, ensure that the barrier is made of a non-conductive material and is securely fastened to prevent accidental contact between the cables. Sixthly, when using a non-conductor like porcelain tubes or flexible tubing to separate cables as per exception No. 2, make sure that the non-conductor is continuous and firmly fixed, and that it provides adequate insulation to prevent electrical leakage or short circuits. Seventhly, when selecting materials for cable separation, consider factors such as fire resistance, durability, and compatibility with the environment, and choose materials that meet the applicable safety standards and regulations. Eighthly, regularly inspect cable installations to ensure that the separation requirements are maintained and that there are no signs of damage or deterioration to the cables or separation materials. Ninthly, keep accurate records of cable installations, including the types of cables used, the separation methods employed, and the locations of the cables to facilitate maintenance and troubleshooting. Tenthly, provide training to personnel who are involved in cable installation and maintenance so that they are aware of the NEC requirements and best practices for cable separation. To further clarify the requirements, let's examine specific scenarios. Firstly, consider a home office setup where a computer is connected to a wall outlet using both a power cable and a UTP cable for internet access. The 2-foot separation rule means that the UTP cable should not be bundled together with the power cable and should be routed separately to minimize interference. Secondly, in a server room where multiple switches and servers are interconnected with both power and UTP cables, the 2-inch separation rule is critical for maintaining network performance. Spaces or cable trays with dividers can be used to ensure adequate separation between the cables. Thirdly, when installing security cameras that use power-limited circuits for power and control signals, it is important to use the correct type of cable that is rated for the voltage and current levels, and to follow the NEC guidelines for cable routing and termination. Fourthly, when running electric light and power cables in a building, ensure that they are installed in conduits or cable trays that are properly grounded and bonded, and that they are separated from communication cables by a sufficient distance or barrier. Fifthly, when using a metal conduit as a barrier between communication and power cables, make sure that the conduit is properly grounded to prevent it from becoming energized in the event of a fault. Sixthly, when using flexible tubing to separate cables, choose a tubing material that is resistant to heat, moisture, and chemicals, and that is securely fastened to the cables to prevent them from moving or coming into contact with each other. Seventhly, when selecting cable ties or straps, choose non-metallic materials that are designed to prevent damage to the cable insulation, and avoid over-tightening the ties, which can cause stress and eventual failure of the cables. Eighthly, when inspecting cable installations, look for signs of damage such as cuts, abrasions, or discoloration of the cable insulation, and replace any damaged cables immediately to prevent electrical hazards. Ninthly, when documenting cable installations, include information such as the cable type, size, and voltage rating, as well as the date of installation and any maintenance performed. Tenthly, when training personnel, emphasize the importance of following the NEC guidelines and the manufacturer's recommendations for cable installation, and provide hands-on training to ensure that they are competent in performing the tasks safely and effectively. Let's delve deeper into the practical applications of these NEC guidelines. Firstly, when running UTP cables alongside power cables in walls or ceilings, consider using shielded UTP cables, which provide additional protection against electromagnetic interference, or ME, from the power cables. Secondly, in areas with high levels of EMI, such as near motors or transformers, use fiber optic cables instead of UTP cables for communication, as fiber optic cables are immune to EMI. Thirdly, when installing cable trays, ensure that they are properly grounded and bonded to prevent them from becoming energized in the event of a fault, and that they are installed in accordance with the NEC guidelines. Fourthly, when using cable glands to terminate cables at enclosures or panels, choose glands that are rated for the cable type and size, and that provide a secure and watertight seal to prevent moisture from entering the enclosure. Fifthly, when installing surge protection devices, choose devices that are rated for the voltage and current levels of the circuits they are protecting, and that are installed in accordance with the manufacturer's recommendations and the NEC guidelines. Sixthly, when labeling cables, use durable and easy-to-read labels that identify the cable type, function, and destination, and that are securely attached to the cables to prevent them from falling off. Seventhly, when testing cables, use appropriate testing equipment to verify that the cables are properly installed and terminated, and that they meet the required performance specifications. Eighthly, when troubleshooting cable problems, use a systematic approach to identify the cause of the problem, and follow the appropriate procedures for repairing or replacing the damaged cables or components. Ninthly, when upgrading cable systems, plan the upgrade carefully to minimize disruption to the existing services and ensure that the new cables and components are compatible with the existing infrastructure. Tenthly, when decommissioning cable systems, remove all cables and components in a safe and environmentally responsible manner and dispose of them in accordance with the applicable regulations. Furthermore, consider the impact of environmental factors on cable installations. Firstly, in areas with high humidity or moisture, use cables that are rated for wet locations and ensure that all connections are properly sealed to prevent corrosion. Secondly, in areas with extreme temperatures, use cables that are rated for the temperature range and that are protected from direct sunlight or other sources of heat. Thirdly, in areas with exposure to chemicals or solvents, use cables that are resistant to those substances and that are protected from direct contact with them. Fourthly, in areas with high levels of vibration or mechanical stress, use cables that are designed to withstand those forces and that are properly supported to prevent them from being damaged. Fifthly, in areas with the risk of rodent or insect infestation, use cables that are protected from those pests and that are regularly inspected for signs of damage. Sixthly, in areas with a risk of fire, use cables that are fire resistant or fire retardant and that are installed in accordance with the fire safety regulations. Seventhly, in areas with a risk of lightning strikes, use surge protection devices to protect the cables and equipment from damage. Eighthly, in areas with a risk of theft or vandalism, use cables that are secured to prevent them from being stolen or damaged. Ninthly, in areas with a risk of electromagnetic interference, use shielded cables or fiber optic cables to minimize the interference. Tenthly, in areas with a risk of static electricity, use cables that are grounded to prevent the buildup of static charge. In addition to the NEC guidelines, consider the recommendations of other standards organizations such as the Telecommunications Industry Association, or TIA, and the Institute of Electrical and Electronics Engineers, or IEE. Firstly, the TIA provides standards for cable performance, installation, and testing, which can help ensure that cable systems meet the required performance specifications. Secondly, the IEE provides standards for networking protocols and technologies which can help ensure that cable systems are compatible with the latest networking technologies. Thirdly, the International Electrotechnical Commission, or IEC, provides standards for electrical safety which can help ensure that cable installations are safe and compliant with international regulations. Fourthly, Underwriters Laboratories, or UL, provides testing and certification services for cables and components, which can help ensure that they meet the required safety standards. Fifthly, the National Fire Protection Association, or NFPA, provides codes and standards for fire safety, which can help ensure that cable installations are protected from fire hazards. Sixthly, the Occupational Safety and Health Administration, or OSHA, provides regulations for workplace safety, which can help ensure that cable installations are performed safely. Seventhly, the Environmental Protection Agency, or EPA, provides regulations for environmental protection which can help ensure that cable installations are environmentally responsible. Eighthly, the Americans with Disabilities Act, or ADA, provides guidelines for accessibility which can help ensure that cable installations are accessible to people with disabilities. Ninthly, the building codes provide requirements for building construction and safety, which can help ensure that cable installations are compliant with building regulations. Tenthly, the local ordinances provide regulations specific to the local area, which can help ensure that cable installations are compliant with local requirements. Furthermore, consider the economic aspects of cable installations. Firstly, choose cables and components that are cost-effective and provide the best value for the money. Secondly, plan the installation carefully to minimize waste and reduce labor costs. Thirdly, use efficient installation techniques to speed up the installation process and reduce labor costs. Fourthly, perform regular maintenance to prevent cable failures and reduce repair costs. Fifthly, use energy-efficient cables and components to reduce energy consumption and save money on utility bills. Sixthly, Negotiate favorable contracts with cable suppliers and installers to reduce costs. Seventhly, take advantage of tax incentives and rebates for energy-efficient cable installations. Eighthly, implement a cable management system to organize and track cables and components, which can help reduce troubleshooting time and costs. Ninthly, train personnel to perform basic cable maintenance and repairs, which can help reduce the need for outside contractors. Tenthly, recycle old cables and components to recover valuable materials and reduce disposal costs. In addition to the technical and economic aspects, consider the aesthetic aspects of cable installations. Firstly, use cable management systems to organize and conceal cables, which can improve the appearance of the installation. Secondly, choose cables and components that are aesthetically pleasing and blend in with the surroundings. Thirdly, use color-coded cables to identify different circuits and functions, which can improve the organization and appearance of the installation. Fourthly, use cable labels to clearly identify cables and components, which can improve the readability and appearance of the installation. Fifthly, use cable ties and straps to bundle and secure cables, which can prevent them from dangling and creating a messy appearance. Sixthly, use cable trays and conduits to protect and conceal cables, which can improve the safety and appearance of the installation. Seventhly, use cable raceways to route cables along walls and ceilings, which can provide a neat and organized appearance. Eighthly, use cable grommets to protect cables from sharp edges, which can improve the safety and appearance of the installation. Ninthly, use cable boots to protect connectors from damage, which can improve the reliability and appearance of the installation. Tenthly, use cable covers to protect cables from dust and dirt, which can improve the cleanliness and appearance of the installation. In summary, adhere to NEC guidelines, consider recommendations from standards organizations, account for environmental factors, address economic aspects, and enhance aesthetic appeal for safe, efficient, and visually pleasing cable installations.